Hello everyone, this is James Boyce for RL Education. Today we're going to be looking at projectile motion and more specifically how to find out how long it takes for this ball to reach the ground after it's thrown off a cliff. The most important thing in projectile motion is being able to think about different directions of motion separately. We used this last week where we wanted to separate our motion down the inclined plane into two perpendicular directions. The reason this was useful is because movement in one of those directions doesn't affect movement in the other one of those directions. You think about it like a graph. As you move up and down the y-axis here, you're not affecting your x-coordinate. Similarly, as you move across the x-axis, you won't be affecting your y-coordinate. So for projectile motion questions, what we're going to do is we're going to use only vertical motion or only horizontal motion to find something out. And then when we get that piece of data, we can use it with the other form of motion to find out something else. And depending on what you're looking for, choosing the correct kind of motion is the most important part of the question. For the question I'm going to be looking at today, we're imagining this ball being thrown off the cliff at 10 meters per second at a 30-degree incline from the horizontal. Now, because what we're trying to find is how long it takes for this ball to hit the ground, the only thing we're going to care about is the vertical motion of the ball, right? Because something hitting the ground depends on its vertical position. If it's above the ground vertically, it can't hit it yet. And its position along this way doesn't affect it at all, assuming we have a solid ground, which we will assume here, just nice and flat. So we're going to call this side of the triangle U for initial velocity, and then subscript V, so we know that it's referring specifically to the vertical velocity. In this case, this just equals 10 sine 30, based on that triangle. And we know, hopefully, that sine 30 is a half, therefore this is just 10 times a half, which is just 5 meters per second. We also know that our acceleration is just going to be given by gravity. So this is 10 meters per second squared. And therefore acceleration here is going to be negative 10 meters per second squared. The reason it has to be negative is because the initial velocity we've called positive 5. And it's going upwards. As you can see here, this triangle, that part's up. Therefore anything going down must be negative to keep it consistent. And lastly, we also have our displacement, x, which is going to be 30 meters. We need to go from here to the ground, so displacement of 30 meters. And again, that's going to be negative as well, because this is motion downwards. Now all we have to do is just put all of this into a constant acceleration formula. We're trying to find time, so we just need one involving initial speed, acceleration, displacement, and time. In this case, that's going to be x equals ut plus half a t squared. We sub every number in. X, negative 30, equals 5t plus half a, so half a is negative 5, so plus negative 5 is just going to be minus 5 t squared. Now we're going to rearrange this so that everything's on one side equals 0, because what we have now is just a basic quadratic. And so to solve quadratics, you always want to put everything on the one side and let it equal 0. So we've got 5t squared, moving that across. Moving this across gives us minus 5t. Minus 30, we don't do anything to that, equals 0 now. Everything here divides by 5, so I'm going to divide both sides by 5 to give myself t squared minus t minus 30 divided by 5 is 6 equals 0. Moving up over here, we now just need to factorize this. So we know that 3 and 2 go into 6, and 2 minus 3 will be negative t. So we're going to have t minus 3, t plus 2 equals 0. And then therefore t equals either negative 2 or 3. I think it's safe to say that if we throw this off this cliff, it's not going to hit the ground at -2 seconds. That just comes up because the motion equation keeps running in every direction, essentially, time-wise, back from before this started, assuming everything else was the same. So if you assume that when time was 0, it had this speed and it had been accelerating at negative 10 meters per second, that means that 2 seconds before that, it must have been moving even faster upwards, and therefore, be down at the ground, right? But it's been coming from below, moving up. Of course, that's not what's happening in our scenario. We're starting from here, so the negative time makes no sense. So we can just say, okay, t does not equal negative 2, and therefore t equals 3 seconds. Once you've done this, as I alluded to earlier, you can go back and use this time to find out lots of other things you might want to find out about this equation. For example, now that we know that t equals 3 seconds, we could go back here, find the initial horizontal velocity of the ball, which won't change, assuming we ignore air resistance, which we are, as there's no horizontal forces on the ball, and then use this to find out how far the ball travels on its path back to the ground. We'll know that it's always moving at whatever speed this is, and we know that it moves at that speed for 3 seconds. So we'll just be able to find this distance here using distance equals speed times time. But I'll leave that as an exercise for you if you want to try it out, and I'll leave you with this question as homework for this week. So what we've got here is, again, gravity's going to be 10 meters per second. This time the ball's being thrown off a 140 meter cliff, and it's being thrown downwards. Again, 30 degrees from the horizontal, this time at 30 meters per second. I want you to find how long it takes for the ball to hit the ground, just like we did in this video. Again, assuming no air resistance. And then secondly, I want you to find what speed the ball will be moving at when it hits the ground. This one takes a little bit more thinking, but give it your best shot.